We're going to determine the minimum or maximum value of these quadratic functions if they exist. So you'll note that both the functions are expressed in standard form for a quadratic equation. So if we're trying to determine a minimum or maximum value, of course with parabolas, it depends on whether the parabola opens up or if it opens down. So we need to kind of acknowledge that aspect first. So for this first example right here, to determine if it opens up or if it opens down, it's just strictly determined by that coefficient of the x squared term, which is a 5, and it's positive. So that does tell you that this parabola is going to open up. Therefore, it only has a lowest point. It has no highest point. So there will be a minimum value of this function, but there will be no maximum value. So now we want to be able to try to determine what that minimum value is, which means that we really want to find where this vertex is going to be located at. And so because this equation is expressed in standard form, to find where the vertex is, you have to first find where the axis of symmetry is, which is always negative b over 2a when the equation is expressed in standard form. So we're going to kind of need to do that part first. So to find the vertex then, we're going to need to evaluate negative b over 2a, which in this case will be negative of negative 60 over 2 times 5, which is positive 60 over 10, which is 6. So you get an x-coordinate of 6, so that tells you that that's going through 6 in the x-axis. But to find the value of the function, we want the y value. So that does mean that we need to now plug in 6 in for x to solve for the corresponding y value. So to get that corresponding y value, we're going to have to do 5 times 6 squared minus 60 times 6 plus 250. So that means we'll have 5 times 36 minus 360 plus 250. 5 times 36 is 180. And then if we go from left to right, 180 minus 360 is negative 180. And then plus 250, and that gives you a final result there of 70. So we get 70 for the y value there. So ultimately, in conclusion, we can say that the minimum value of this function is 70, therefore. For this other example, the function k here, we see that the coefficient of the x squared term is a negative, which then means that the parabola is going to open downwards in this case. So there's going to be a maximum value of this function k, but no minimum value. So we'll conclude by trying to find what the maximum value of this function is going to be in a little bit. So to find the maximum value, of course, you want to find where that vertex is going to be located at for this particular parabola. So to be able to work to find the vertex here, because this equation is in standard form, then we know that the axis of symmetry, which is the x-coordinate of the vertex, also is going to be negative b over 2a. Now, there isn't a middle x term, so your b value is a 0 over 2 times negative 2, since that's your a value. So that really just simplifies to 0, so you know that the x-coordinate of the vertex of this parabola will be 0. And then if you substitute that 0 into the equation for x, then you end up just getting a positive 9 for a y value, of course. So then 9 is going to be the corresponding y value, and so then that tells you then that, of course, then 9 is the highest height of this parabola, so the maximum value of this parabola is going to be 9. Now, with this particular example, I do want to help you recognize the fact that negative 2x squared plus 9, while it's in standard form, is also in vertex form, so you could actually think about this as being negative 2 times x minus 0 squared plus 9. And so because it's in vertex form, then you could just explicitly see that, oh, hey, yeah, 0, 9 is going to be where the vertex is at. And then, of course, from there, since the vertex is going to be the highest point when the parabola is facing down, then you would know that 9 is, of course, going to be the maximum value of that parabola.